So hello everyone, today we are going to talk about seasons. Now seasons is a division of year based on changes in weather. Now why do these occur? So we have asked this question to several students and the answers that we got can be divided majorly into two responses. The first one being that seasons occur because of the change in distance due to the elliptical orbit. Now this change in distance is between obviously Earth and Sun. So we all know that Earth goes around the Sun in an elliptical orbit, and because of this orbit, because of the ellipticity of this orbit, in some parts of the orbit the Earth is closer to the Sun, whereas in other parts it is far away from the Sun. Now when it is closer to the Sun, obviously the flux at Earth is going to be more and hence the temperature will increase slightly. Now this is a logical argument, but if this was the case, entire Earth would experience the same season at the same time. But we all know that this is not how it is, right? When we experience summers in the northern hemisphere, the southern hemisphere have winters and vice versa. Also, when the Earth is closest to the Sun, that is around 4th January, in the northern hemispheres we have winters, whereas when it is farthest from the Sun, that is around June, we have summers. So this is clearly not the reason. Then what is wrong? So the distance between Sun and Earth when Earth is closest is around 147 million kilometers, and when it is farthest it is around 152 million kilometers. So this change in distance from nearest to farthest point is only about 3%, and the change in flux because of this, it comes out to be 7%. Now this is a very small number, and it is very small as in to contribute to any temperature change which will lead to any change in seasons. So this is not the reason. The other answer or the response that we got was change in distance because of the tilt of the Earth. Now we all know that the axis of the Earth is not perpendicular to the elliptical plane, but it is slightly tilted with respect to the perpendicular to this elliptical plane. Now this angle being 23.5 degrees. Now if you see in this figure, so Sun is in obviously on this side of the figure, and this is Earth which is tilted, and it will appear as if the regions in this part, that is the northern hemisphere, are a bit closer to the Sun as compared to the southern hemisphere. Now to verify this fact, what we can do is, we know the radius of the Earth, which is 6,400 kilometers, and we know the average Earth to Sun distance, that is around 150 million kilometers. Now this particular distance, that is the radius of the Earth, is only about 0.004% to that of the Earth to Sun distance, which is very small to cause any significant difference in temperature that can lead to seasons. So then back to our original question, why do seasons occur? For this we are going to take a look at this particular figure. So we have Sun on this side of the screen, and this is Earth. Now this is the position of the Earth at equinox. So if you look at the equatorial region here, the Sun is going to be overhead at noon. We are going to take a look at the same amount of sun rays that are falling on different parts of the Earth. Now if you look at these particular sun rays that are falling at the equator, they are covering certain area on the surface of the Earth, whereas these sun rays, that is equal amount of sun rays, they are falling a little bit in the northern hemisphere, little bit north to the equator. They are covering a larger area. So same amount of sun rays are covering different areas when they fall on the Earth. Now this area being small, the intensity of the sun rays here will be more, and the temperature will obviously be more as compared to this region where the intensity of sun rays is going to be smaller than that in this case. So this is nothing but the reason for the difference in temperature, and this leads to seasons. Also, while reading about seasons or hearing different videos, we come across these terms, that is direct or oblique rays. Now let us understand what these are. So we often read that during summers, the northern hemispheres, they receive direct sun rays. So let us see what this term actually means. So this is the position of the Earth in the month of June, when there is summer in the northern hemisphere, okay, or this is the summer solstice. What we are going to do is, we are going to look at the angle made by the sun rays with respect to the tangent to a particular location on earth. In this figure being 23.5 degrees north, okay. So this angle clearly, as you can see in this picture, is 90 degrees. This is what we mean by direct sun rays, whereas at this particular position only, if you look at the southern hemisphere or 23.5 degrees south, these sun rays are not perpendicular, whereas they are a little bit oblique. So in this case, we can say that this position represents summers in the northern hemisphere, because the intensity of the sun rays here will be more, whereas the intensity of sun rays here will be less, because same amount of sun rays are getting distributed over a larger area in the southern hemisphere as compared to the northern hemisphere. This is the position of earth at equinox. If you see, direct sun rays are coming at the equator, or the angle made by the sun rays with respect to the tangent to the equator is 90 degrees. Similarly, in the third case, that is during the winter solstice, you can see that the angle made by the sun rays with respect to the tangent to 23.5 degrees south latitude is 90 degrees, whereas all the other regions of the earth, they receive oblique sun rays. So this is the position of winter equinox or summers in the southern hemisphere. We have talked about two seasons, that is summers and winters, and those are purely related to the tilt of the earth's axis. Now during the entire year, there are also some months in which we have some other seasons like monsoon, and these are purely based on local phenomena, and they have nothing to do with the tilt of the earth's axis, and hence we have not included those in this particular video. Thank you.